Good morning. Oh, a little loud. How's everyone doing? Thanks for coming out to the last day of the Build Conference. Really appreciate you guys being here. Who all saw the Avengers last night? Was it cool? Awesome. Hope you guys have had a great time. I know you've seen a lot of PowerPoint. Confess I've got a few more slides for you, but I've got a lot of cool demos. We're going to spend a lot of time in Visual Studio and look at a lot of code. For the slides I do have, you can rest assured that PowerPoint was harmed in the making of this presentation. So, I'm David Mebane. I'm a program manager on the media team here at Microsoft, and it's really my privilege to be here today talking to you all about what we've done to make it easy and awesome to build audio and video applications for Windows. I think I'm supposed to tell you, review the session afterwards. We really appreciate the feedback. It helps us make sure that we can give you better and better presentations at each Build Conference. So if you could take a few moments, we'll appreciate it. Before we get into the content of the talk, I wanted to take a moment and step back and reflect on what the goals that we had as a media team were for Windows developers with Windows 10. First and foremost, we wanted to give you what you asked for. We heard a lot of feedback from you that things were hard, that it could be easier, that we could do a better job making you successful and productive on our platforms. We heard that feedback. It wasn't always easy, but we heard it loud and clear. We've listened to it, and we've delivered on it. We've given you the top things that you asked for with Windows 10. Second, you've heard about it a lot, but it's critical. It was a shared goal with everyone here at Microsoft to make it possible for you to write one piece of code that runs across all Windows-powered devices, giving you that reach and that scale, that billion devices that Terry talked about the other day, we believe is critical for making you successful. We want you to get the maximum return on your investments when you target the Windows platform, and we've really taken that on as our mission within media to deliver on that. Finally, we want to allow you to focus on what makes your app great. Media is a somewhat unique space, and that there's a lot of value provided in a lot of different parts of the stack by a lot of different companies. Some companies are really selling the content that they provide to users. Other companies are selling the services and application development and even specific areas of that. And so we wanted to make it really easy in the language of your choice, be it C#, JavaScript, C++, whatever you prefer, to focus on that unique value that you're providing to the ecosystem and let Windows handle all the other stuff. All that stuff that's hard that you don't really want to be writing code for, we're taking on that work and we're making it easy for you to focus on your key value. So what we'll talk about today, we'll spend the first half or so talking about building converged audio apps and how you can write that one audio app that runs on all devices. And then we'll build on what we learned with the audio and talk about how you can add advanced video experiences to your app, and it's super easy. We've taken things that used to require thousands of lines of code and dropped it down into a handful of lines. So I'm really excited. I think you're going to love what we have in store. Before we get into it, I just want to be really clear. I get a lot of questions on this. That everything I show today runs on every single device running Windows 10 with the Universal Windows platform. Everything I show will run on devices from PC, phone, tablet, Xbox, HoloLens. Whatever we come up with next, you write this one set of code, it's going to run there, and your customers are going to love it. So let's get into it. When you think about building an audio application, the first thing you really want to think about is how your user is going to use that application. Most people, probably almost every day when you listen to music or other audio files on your PC, what you do is you load up your favorite app, you set what you want to listen to, be it some CD content that you've ripped to your library, files you've downloaded or you're streaming. You set up whatever you want to listen to, and then you go do something else. You don't stay in that app. You're going to be writing code. You're going to be surfing the web. Maybe you're cooking dinner. Doesn't matter what you're doing. All that matters is that you're not running the audio application anymore. And so when you think about building an audio app, it's important to think about this user interaction model and really design for background audio. When I talk about background audio, I'm really talking about that experience where the users minimize their app and they're doing something else, but they want to keep listening to your music and loving the experience that you provide. In the past, we had different stories for background audio on different devices. The code you had to write on your PC was different from the code that you had to write for phone. We wanted to make this easy, converge it, and so we've taken the approach that we pioneered on Windows Phone, and we've brought that to the full range of devices. How this approach works is it's actually a two-process-based approach, and I'll get into the reasons for that in a moment. But the first process, as you'll see, is this rich player app. That's all the UI and everything that your user is going to interact with and figure out what they want to listen to and tell you what to play. The second process is a low-memory background task. This task communicates with your player app so that you can tell it what audio files should be played, and then it's responsible for actually playing those files. And the reason that we take this two-process approach is because Windows runs on this huge range of devices that you've heard about. For really high-end desktops and high-end phones and stuff, there's a lot of resources available. But on a low-end phone, if you think about the $75 phone that someone's buying because they broke their phone and they don't want to shell out $600 or they're in an emerging market, these low-end devices don't have a lot of resources available, and you want to be really careful about how those resources are utilized. So by splitting out the UI code from the actual media playing code, it allows us, the operating system, to go tear down this UI. When the user goes and they start browsing the web, we can tear down all that UI and free up those resources for other things. And that's great for you as a developer, because by enabling the operating system to be really efficient with these resources, we get a lot of power savings so that we can keep your app running as long as possible. So we think this provides a lot of value for both the users of your applications and you as a developer in terms of keeping your app in front of the user. You do all the communication and the playback through a background media player object. This is an object that the operating system provides to you, and it facilitates two main things. It allows you to communicate between your background task and your rich player app so that you can keep these two items in sync and working together well. And then it also provides you with the media player that you use to actually play the audio content. So you'll use this player, and this gives you kind of the core experience that you want for the app, but there's one more piece to the puzzle, and that's the system media transport controls. I like to think of these as the operating system level UI that the user sees. So after they've gone and they're browsing the web, they might hit a song that they listened to recently and they want to skip over it and listen to something new. If they're on a desktop, they might hit the next key, media key, on their keyboard. And by interacting with the system media transport controls, that's how your background task can receive those events, and it can know that, hey, I need to skip to the next track, or the user just changed the volume. And so you get all of that operating system level interaction that the user is going to expect to be available for them when they go and actually run your application and use it in conjunction with other apps. So you want to, as you start to write a background audio app, take a few minutes, look through the sample we have on MSDN. It does a really great job showing you how all of this works together, and just kind of make sure that you understand the architecture that you want to build. By taking a few minutes up front and getting that architecture in mind, it sets you up for success so that you can build a really great application down the line. And it's really easy to send these messages with the background media player. So in this case, we've just got a really basic scenario where the user's in your application UI, and they've clicked the next track button. They want to listen to something else. Using the background media player with the send message to background method, you can just send a string. In this case, I've chosen next, but any arbitrary string that you want to send, you can send from that foreground process to your background process. And it'll receive that string, and it'll process it and know, hey, when I get the keyword next, I need to skip to the next track. The user doesn't want to listen to this anymore. So it's really simple to get these basic messages, but we also know for a lot of you, you want to build something more complex where string passing isn't sufficient. And so we also support sending value sets. In this example, and it's what you'll see if you go download our MSDN sample, since we think this is really the way a lot of you will want to design your applications. In the MSDN sample, you'll see that there's three projects in the VS solution. The first project is that rich player app UI I mentioned. The second project is that low memory background task, and the third is has some shared classes between the two that are used for communication. So in this case, we've defined a message service class that can send a bunch of classes that we've defined. So you've got a skip next message class, a skip previous message class, and a bunch of other ones. And what's powerful with these classes is you can define them as data contracts, and then you can use that to send rich information between the two. So in this case, when you send the message to the background, we'll create a value set. And the first item in the value set is the name of the class that we're sending. And then the second item we add to the value set is we serialize that class to JSON. It's a stylistic choice. You could set it serialized to XML or any other format of your choice, but you serialize your class. And then you take that value set and you send that to your background task. Your background task is then able to go and parse all of this and get rich information. Perhaps you wanted to send how long the user was listening to that track so that you can take some action on that or build some analytics. You can do all that here. So with that, let's jump into a quick demo and see what I'm talking about. Let's see. So sorry about that. First and foremost, what I have here is I've just got a foreground audio app. And you'll notice when I minimize that, audio cuts out. Real simple, just kind of demonstrates why background audio is important. In this case, what I have here is I've got the Windows 8.1 music app, which has implemented background audio. And you'll notice now when I play music, I can minimize the app and audio will keep going. What you astute listeners might notice as we're listening to these tracks, however, is that there's those audible pauses between each track. And the reason that those audible pauses exist is because in Windows 8.1, we did not have support for gapless audio. And this has been a top customer pain point that we've heard in the past from both developers and users. And I'm really excited to announce that with Windows 10, we've added support for the platform with background audio. And what I love about the approach that we've taken is that we really solve two developer pain points with one solution. We've added support for a set of playlist APIs that make it really easy for you to manage these playlists. It works for both audio and video files. And when you use these playlist APIs, you get gapless audio support for free out of the box with no additional code required for you. We do this in two ways. First and foremost, we look at the files that you're playing. When those MP3s are encoded, it's possible for the encoder to write a set of metadata to those tracks that details exactly where audio silence exists. Stepping back a moment, a key source of those gaps in the playlist is that when audio is encoded, the encoder can write a little bit of extra white space between it. So if you're ripping a CD, that's a common source of it. So the encoder can detail where that space has been added. And then when we play back those tracks, we'll parse that metadata and we'll snip out those little pieces of space so that you get that gapless experience. At the same time, we recognize that a lot of users, they don't know what encoder they used when they ripped their CD library. And they don't care. They just want all of it to work. And they don't want to understand, hey, why do these files play back gaplessly and why do these have gaps? And so to support those files that do not have that metadata present, we've also added a set of heuristics to the platform. And so when we're playing back any other audio file, we'll use those heuristics to sniff out where has some white space been introduced, and we'll slice that out again so that no matter what file you're playing, you'll always get gapless audio. So I've got a code slide, but let's go ahead and just jump into Visual Studio. So what I've got here is this is just the, this is a modified version of the MSDN sample that we've got online for you. And the code that you see is the code for actually creating one of these playlists. The first thing you do is you go and create a new playback list object. And in this case, we've enabled looping on that as well. We have a list of songs, and we'll just iterate through those songs. And for each song URI that we encounter, we'll create a new media source. We set a couple custom properties in this case, and this track ID and a title key. This is totally optional, but we think will be really nice for you as developers because it provides a way for you down the line to go query and see, hey, what's the track that's playing? You could go look up the track ID and title key to see what the user is listening to when they hit that skip next button. So once you set up your source, you're then going to turn that into a media playback item and add that to your playback list. We go through, we add all of our items to the playback list, and then you simply set that as your source on your background media player. And you'll see that now when you hit F5, sample will come up, and now when we listen to it, we'll get a gapless experience that seamlessly switches between tracks. And you can even minimize it, and everything will keep playing. Your users are listening, and they have no idea what track we're on. We could be on track 2, track 3, track 4, doesn't matter. So we think that you're going to love this as a developer because it makes your life easier writing these apps, and your users are going to love the fact that you've got gapless audio support. There's one last thing to keep in mind when we talk about audio, and that's that we've talked about music a lot right now, but there's a lot more audio that gets played through the platform. From movies and music to communication to games, there's a ton of different audio, and those different categories of audio have different expectations in terms of how the audio is processed and used. For example, if you're listening to a movie, you want the user to be able to hear the quiet whispers to the loud explosions, and to do so in a way that doesn't have them constantly fiddling with the volume control in order to get a good experience. A communication app, on the other hand, you really want to make sure that the vocals come through clear and crisp and understandable. And so there's different filters that you want to provide for these audio categories. And so we've defined a set of categories in the platform. It's really easy for you as a developer to set. You just set it on your media element and never worry about it again. And then Windows will take this information and we'll use that to communicate with the audio driver to make sure that we provide the best possible experience when your users are listening to audio. So we think all this is really great. It'll make it really easy for you to write one audio app that runs on all those devices. And when you think about these audio categories, it's important to remember them when we talk about video as well. In video, you're generally going to set the movie category and playback. When you think about video today, however, one of the big things that you hear a lot is the term adaptive streaming. Adaptive streaming is how you can target that huge range of devices that'll run from the small phone on a 3G network to your Xbox with a 4K TV and a really fast internet connection. It's a way to have a set of video files that provide the best experience for each user on each device running on any network. Real quick, for those of you who aren't familiar with the term, adaptive streaming, it's kind of this a term that refers to a collection of technologies that can be used to provide that great experience on devices. And at a high level, how it works is you've got your video file that you actually want to play back on all these devices. You can then take that file and you can encode it in a bunch of different bit rates. So you can go from really low quality to really high quality with different bandwidth requirements for supporting each of those. And then you can chop all of those video files up into a bunch of segments. These are 2, 4, maybe 10-second chunks of video. And then you have a manifest file. This is all on the server. You have a manifest file that describes, here's all the video content that's available. Here's how I can access this content. Here's how you can download it and play it back for the user. There's a lot of solutions out there for how you can create this content. For example, Azure Media Services has a great set. They've got a talk on this at 2 to 3. So if you want to learn more about the service side of this, I'd encourage you to go to that talk. But regardless of if you use Azure or another service provider, you get all your content up in the cloud. And then on the client side, you have a streaming client. This client's responsible for downloading that manifest, determining what content's available to play, and playing back the best content for that user and that device. So it's going to select an initial video segment to download. It's going to download that and start playing it back to the user. And while it does so, it's going to be monitoring network conditions. It's going to figure out, is this the best file for this user on this device? If files are downloading really fast and there's a lot of extra bandwidth, it'll go switch to a higher quality video so the user gets a better viewing experience. On the other hand, if the files are downloading slowly and there's not enough network throughput to support playing back that file without buffering, it'll switch down to a lower quality bitrate so that you can ensure that you avoid those painful buffers and provide a great seamless viewing experience for the user. So as it's playing back this content, it's constantly downloading new segments and switching between them to provide the best possible experience. Some of the common technologies that we see in use a lot today are HLS, which is a specification that's developed by Apple, and they actually require it for streaming to iOS devices over cellular networks. There's Dash, which is an ISO standard that's seeing really broad adoption, especially in parts of the world such as Europe. And Dash it's an ISO standard, so people really like to reference it and build on this solution that's interoperable and available to everyone. And the third one is smooth streaming, which is the technology that Microsoft developed a handful of years ago for solving this same problem. And with smooth streaming, we actually took all of that technology, we published all of the specifications, released all of the IP related to it, and it was one of the key inputs into the Dash Industry Forum as they defined the initial standard. So we like to think of Dash as smooth streaming plus inputs from a lot of other companies and technologies and kind of the conglomeration of the best ideas that we've seen in the industry. And it's a really great solution that people are starting to roll out today. Overall, as a company, however, we know that there's a lot of content that exists today we want to make sure plays great on Windows, and there's a lot of content that's coming from the future. So we're really committed to interoperable media. And so in the past, while we only had the Smooth Streaming SDK available for Windows and Phone 8 and 8.1 applications, we've also gone ahead and we've added support in the platform for both the HLS and Dash protocols. Yeah, you can cheer. This is awesome. Let's go. So when I say we've got platform support, I mean that it's as easy as with one line of code, you can get fully adaptive streaming HLS and Dash content. And that's available for both applications and websites. You can set the source of either a video tag or a XAML media element to an HLS or Dash manifest, and we'll handle everything from there. We'll download the manifest, we'll parse it, we'll play it back. This is really powerful. We've also gone ahead and we were updating the Smooth Streaming SDK for Windows 10. So for all of you who use that to build 8 and 8.1 apps, this SDK will be available. It's going to be online very, very soon. And it'll make it really easy for you to go ahead and take your existing 8 and 8.1 app and move it to Windows 10 and not have to rewrite all of your video streaming code. So this is really powerful for apps and sites, but we also recognize that a lot of people want support for customization. They want to tweak some of the experience without having to go rewrite go write an entire streaming client. So a common use case that I've heard from developers is that they want to control the initial bitrate that's downloaded and played back. This is powerful because there's a lot of different user experiences that can be delivered with that initial bitrate. For example, if the initial bitrate's the lowest quality stream available, you're going to get really, really fast time to first frame. It's going to be like that, and you're going to be playing content for the user. And then you can ramp up to a high-quality stream from there. Other people prefer starting at really high quality, and they don't want to see that ramp up. And so they'd rather take a little extra time up front and get to that really high-quality first frame so that your video looks great from the moment you start. So we've got APIs for this so that you can control what the initial bitrate is, along with a bunch of other customizations. We'll look at a few when we get into the code, and there's a lot more. It's all on MSDN. So we think that we've provided a great set of default values and provide a great default experience. But we don't want to be a dictator for how streaming behaves on the platform, and so we want to provide you with that customization. And to that end, we know that some of you want even more customization. In Windows 8.1, we added support for MSE. It's a set of W3C APIs that make it really easy in the browser to build an adaptive streaming application. It allows you to parse the manifest and start downloading those video segments and play them back without having to actually process any of the video segments. You can just feed them in as a buffer. Developers have been really happy with this technology, and we've seen a lot of uptake. We wanted to make that easy for all you XAML developers out there as well. And so we've gone ahead and we've created a WinRT projection of the MSE API surface so that you can use that from any language of your choice. This makes it really easy, removes a lot of boilerplate code that you had to write for building a streaming app. So for those of you who desire that fully custom solution, this should be great for you. It works with Media Protection Manager for DRM in the XAML C# case. And not only have we added support for MP4, which we had in the browser with 8.1, but we've also added support for MPEG-2 transport streams, which is the container used for HLS. So you can go ahead and use this technology for building both custom Dash and HLS players, as well as smooth streaming. So let's look at some code and see just how easy it really is to add this to your application. Let's see. That is not the right one. All right, cool. So what I have here is I've just got a blank C# project that I created. I'm demoing in C# today because it's the language that I'm most comfortable in, but if you prefer JavaScript or C++ or another language, it works the same for you there. So I've created the blank project so you don't have to watch me get that open, and we'll just go ahead and start by putting in some really basic UI into the application. We can go ahead and build it. What you'll see is we've just got a grid with 3 rows. The first row has just a text box and a button where you can set whatever manifest you want to play. The application we're going to build today, by the way, supports playback of both HLS and Dash content. There are 0 API differences between the 2 streaming technologies. So it makes it really easy if you're considering a move, for example, from HLS to Dash. This is a great way to support your existing library and your new content as it comes online. So we've got the text box that takes in a manifest, the play button, some media transport controls, and just the copyright attribution at the bottom. But obviously when I click play, nothing happens. We need to actually go and wire up support for adaptive streaming. So how you can do that is, first off, we need to add support. We need to add a click method handler. So you can add the event, and then using F12, it's really easy to just pop over into your CS file and add support. So what we do is, with the first line of code, we go ahead and we grab the URI that's from that text box. We convert it to a system URI. And then we'll set that as the source on the media element. And that's it. We'll go ahead and run that project, and we'll start streaming back. In this case, I believe I have an HLS manifest in there. And when you click play, it's downloading that manifest and playing it back.
Why don't you just admit that you're freaked out by my robot hand?
So this is awesome. In 2 minutes, you've gone ahead, you've built an application that's capable of playing both HLS and Dash content. It's fully adaptive, makes it really easy for you. But I know you're sitting there and you're saying, well, that's great, but I've seen a lot in the news about closed captions, and I've heard from lawyers that I have to support closed captions if I'm in America, and it's also just really important that I support all my users. In the past, for closed captions, we've seen a lot of people have used the Player Framework SDK that's open source online for adding those closed caption experiences to your app. It's hard. It's not code that anybody wants to write. And so we've gone ahead with Windows 10 and added native support for closed captions to the platform. It supports all the top formats and delivery mechanisms today. You can have 608 or 608 and 708 captions in your SEI header. You can use TTML. You can use WebVTT, bunch of other caption formats. Whichever one you're using, we support that, and we've got a place in the OS where the user can customize it. This is really powerful. Think about it for a moment. You can, in the case of using in-band closed captions, for example, with 0 lines of code, you meet all of your FCC requirements, and your users have a great experience. If you want to add support for out-of-band, there's a few lines of code that you need to write. So the first thing you need to do is you need to initialize your adaptive media source. Your adaptive media source is the underlying source that was created when we set that manifest on the media element. And so by default, we'll go ahead and we'll wire that up and create it for you. But if you want to use closed captions or some of those customization APIs I mentioned, you need to add this into your app. So the first thing we'll do is we'll go ahead and we'll add that. And now, rather than setting the manifest on the media element, we can call this method that we've created. we'll just pass in the manifest that we want to play, or the URI to it, as well as the media element that we want to play. And in here, what we do is we create an adaptive media source creation object. And that object tells us if we were successful in creating it, or it'll provide a bunch of error information if we weren't able to create it, either due to a bad URI or network conditions or many other errors. And then, once it's created, we can go ahead and grab that media source. And I'm going to quickly, up here at the top of the class, I'm just going to define this object to make it really easy for us to work with while we're going through this project. So we've got our adaptive media source object, and now we need to go ahead and add closed caption support for it. If you're building a real application, you're probably going to have your closed caption file hosted online somewhere that you're downloading. But for the sake of this demo, I'm just going to grab a TTML file that I added earlier today. So you can take a look. This is just standard TTML. We're going to go ahead and tag this as content so that Visual Studio picks that up properly for the build process. And then what we're going to do is we're going to go ahead and tag this TTML file as a closed caption track and add it to our media source. So the first thing we do is we go and we create a media source object from our adaptive media source. Next, we're going to grab the URI to that TTML file, and we'll use it to create a time text source. And with that time text source, we can then add it to our media source. So now we've associated the adaptive streaming media source with the TTML source so that we can play those back in the sync. Once you've got your source created, you can then create a media playback item and set that item on your media player. And now when we run the application, we'll see not only do we have a fully adaptive app, but it supports closed captions as well. So we go ahead and click play.
Why don't you just admit that you're freaked out by my robot?
And you'll notice that we've got a closed caption button that's now been automatically added to the media controls. Windows has picked up that closed captions are present in the file. We've put that button there, and you can turn it on. And you'll see that we start playing these closed captions. But as we all know, it's not just sufficient to have captions. They need to be user customizable. And to do that, you can go ahead and go into the Settings application. And under Ease of Access, you'll notice that we've added a closed caption tab. If you go there, there's a ton of different customizations the user can set. They can specify their font, the background, etc. So perhaps we'll say for this example, I really like my captions in red. I think that it makes it a lot easier for me to read. And so I can go ahead and set that up. And when I click play, you'll now see the captions render in red. So this is really, really powerful. And it's great for users as well, because they can just go set up their preferences one time, and then it works across all of their video applications. You don't have to write any code. Users get the experience they expect. We think this is a huge win for the platform. If you do want to write your own renderer, I will mention that all of the queue objects that we were setting there, they're all available to you, so you can go pick up all of those caption queues and do whatever you want with them as well. So this is really powerful. But we know that with Player Framework, there was another key scenario it was used for, and that was for customizing the controls. In the past, the media controls were not easy to customize, so you couldn't make them fit in with the look and feel of your application. We've gone ahead and we've added support to the platform for customizable media controls as well. So it's really, really easy for you to take your app and make it look great with the UI that you've built. So for example, let's say we want to add a little color to our application. I know my boss, she absolutely loves orange. It's her favorite color. She's always telling me that orange is the new black, and so I want to add a little orange in there for her. What you can do is you can just add a resource dictionary to your app.xaml file, and there's two key brushes that you want to update. The first is the system control highlight accent brush, and the other is the system control foreground accent brush. I set these both to orange, and now when I run the application, you'll see that we've added a splash of orange to the app, and so it starts to look better. I know my boss is going to love having this orange.
Why don't you just admit that you're freaked out by my robot hand?
So it's super easy, and we think that this will go a long way towards making the UI fit in better with your app. At the same time, however, we know that a lot of you want to do even more advanced things. You want to update, you want to add new buttons, you want to disable buttons, you want to change the dropout order. And when I say dropout order, what I mean is that on a 10-foot screen, the Xbox experience, you could fit a lot more buttons on the timeline than when you're on a 3-inch phone. And so we've got a way for you to do all of this and more. And how that works is you can just go ahead and grab the generic.xaml file from your SDK. So everything that we showed there, it's all XAML that's available for you to go ahead and use to build a custom set of controls for your application. And it's really easy to do so. All you have to do, is go to your, I've got the SDK here. It's a big long path. It'll be on MSDN. It'll be easy for you to find. Don't worry about writing this down. You can just grab your generic.xaml file. And what you'll see is that this has all of the code that's used for UI throughout the applications. Go ahead and open this with Visual Studio. You want to make sure that you do an open with and select Visual Studio so that you can get access to the code. So now you can just go ahead and search for the media transport controls. And you'll find them down here on line 12,381. Go ahead, minimize that, and just copy and paste the whole thing. You take it back to the application that you're building. There's a few quick things to do to wire it up. The first thing I'm going to do is I'm going to add a new folder to store this file. So we'll call it themes. And then within this themes folder, I'm going to add a new resource dictionary. And we'll call it generic.xaml. Generic.xaml is nice. It makes it easy for the purpose of the demo because it just automatically gets picked up when your application runs. We'll go ahead and update this so it's in our main namespace. And then we just want to paste all that code that we grabbed. And you'll see it's a lot. It's 1,200 lines of code or so. And that's because we're doing a lot of things on your behalf that you don't want to do. There's only a few hundred or so lines of code in here that you actually care about. And so you can get rid of all the resources, all the visual state stuff, all that management that you don't care about, accessibility support. These things that are important for building a great application, but that don't really give you any value. You can minimize that, ignore it, never worry about it again. Then you can come down and you'll find the command bar section. The command bar is where all of the controls that we've seen on the UI actually exist. They're listed in left to right order, and there's a couple key properties to note here. The first one is the dropout order. The dropout order specifies as your application scales from large to small or from small to large, which buttons take precedence for appearing on the UI. So in this case, the stop button, we have that by default set to a dropout order of 1, which means that if you can't fit every single button on the screen, it's going to be the first button to fall off. That's because there's play and pause that the user can use to generally get the same effect, and we don't see a lot of usage of that. In fact, because we don't see much usage, it's also set to collapse by default. You can either turn it on through the XAML here, or we've also got APIs for turning on buttons as well. And so you can look through and you'll see that we've got a lot of great buttons for you by default. Some are on by default, some are off but available for you to use. And there's a couple key buttons. One of them is the closed caption button that we talked about earlier. This is set to collapse by default, but we'll handle turning that on and off for you. Because captions are such an important part of the user experience, we automatically turn that button on when they're present so that the user's always in control and you don't have to worry about when captions are present or not. The other button that will do the same thing for you is with the audio track selection button. There's multiple audio tracks in the file that you're playing, whether it's either an MP4 that you're playing locally or if you're streaming content over the web, we'll light up that selection button whenever it's appropriate so that the user can switch between, say, English and Spanish. So we've got a great set of buttons for you, but as we mentioned earlier, there's a lot of strong opinions around how streaming should behave and if you want high quality or to start at low quality and stuff. Personally, I really like seeing my videos in high quality all the time, and I want to add a high quality button to the application that when clicked just locks on to the highest quality bitrate and streams at that. I'm willing to risk some buffering and a lower quality experience in that sense so that I get that real crisp video experience. So this is really easy with our new controls to go ahead and add that button. We just create a quick button. I've set the dropout order to 11 because this is really important, in my opinion, for the quality of the experience for the app that we're building today. And I've gone ahead and I've made that visible. And you can see that I've just gone ahead and it'll just show up as HQ on the playback timeline. So once you've gone ahead and you've added this, you want to make sure, by the way, that you update your target type here so it's referenceable by your app. So we'll call it our custom media transport controls. And then we'll go back to our main page.xaml and we'll add these controls to the media element. So we reference those transport controls, and you'll see here I'm also turning on a couple buttons. I've turned on the playback rate button and the zoom enabled button. I think those are important to the user experience, and I really like the playback rate button because sometimes I have to watch training videos and I want to be able to turn that on to a faster speed and get through it quicker. So once you've added that, there's one more piece that we need to do, and that's we need to go ahead and add a new class. We'll call this our custom controls.cs file. Within this class, we'll go ahead and wire up our buttons. So we create a new instance in the media transport controls. We'll go ahead and reference that namespace. Just apply the template. And so now when you hit F5, we'll see that we've added our high quality button to the application. So this is awesome, but it doesn't do anything. There's no way, we haven't added support for actually locking onto that bitrate. So let's go ahead and do that now. The first thing that we need to do is we're going to go define a new event that handles when that high quality button's clicked. And then we're also going to have a button that tracks the visual state because we want to highlight that button when it's on and disable the highlighting when it's off. So now what you'll see is when that button's clicked, assuming, first we check to make sure that our application's actually registered for that event. If it has, we go ahead and we fire the event, and then we update the UI. So we're just updating the foreground property on that HQ text block that we had. And we're setting it to orange, so it fits in the look and feel of our app when it's enabled, and we'll toggle it back to white when it's disabled. Next, we'll go back to our application, and we'll handle that event. So when that button's clicked, we're also going to quickly add a reference to a variable that we'll use for tracking the state within this as well. And we'll have this disabled by default so that we get adaptive streaming. Now, when the button's clicked, let's see. We're going to use a couple new properties. If you look at the adaptive media source, you'll see that we've got a ton of different properties: download bitrate, playback bitrate, a lot of events for you. It's all on MSDN. I encourage you to check it out there and play around with it. In this case, there's two things that we need. We need to be able to set the minimum bitrate. So we can set this so that our streaming algorithm will never go below that bitrate. And then we want to set that to the highest quality bitrate that's available. So we can use this available bitrates property that gives us a list sorted from low to high of all the bitrates available. By setting the minimum bitrate that we stream with to the highest quality bitrate available, we're effectively locking on to that high quality bitrate. And we'll go ahead and track that as enabled. When the button's clicked again, we can go ahead and set that to null. You can set the max bitrate. It's not necessary for this demo, but you set it to null, and that'll reset it so that you can switch back to streaming adaptively. The last thing we need to do is we need to actually register for the event so that this code's called when it's clicked. So we simply handle that event, and now when I hit F5, we'll be able to actually play the application and lock on to a high quality bitrate.
Why don't you just admit that you're freaked out by my robot hand?
And so you can see it's been updated. It's a little, we have really fast internet in here, and so it's not necessarily easy to see that we're locking on. But we've got bit rates that show you the download and playback, so I encourage you to go take this code later and prove it out, and you'll see that we switched to that bit rate. So once that button's clicked, all future segment downloads will be at the highest quality bit rate, and you can go ahead and turn that button off as well. So this is all super powerful, but I kind of feel that we're getting a lot of controls on our main playback timeline. It's getting crowded, and I just want to highlight some of the best controls to keep the UI clean and simple for the user. If you want to do that, you can go back to the generic.xaml file we created with our custom controls. And then down here, you'll notice that we've had, within our command bar, these are all primary commands. You can also add a set of secondary commands. And these are all commands that will show up in an overflow menu that when this is created, we'll see in a second. So in our case, I think the playback rate button and the zoom buttons that we turned on, those are really important to the overall experience, and it's important functionality. But it's kind of a niche audience, and so we want to put that in the overflow menu. So it's available just for the people who want to see that. You can go ahead and you can delete all this code. All you need for the overflow menu is to set a label. We'll call this one playback rate. And then for zoom, we'll go ahead and call that zoom. So now that we've moved the buttons here, you'll see when we run the application, they no longer show up on that main timeline. And now we've got this overflow menu. So now when you click this, you can see we've got the playback rate. And playback rate, for example, gives you a bunch of great default options. But again, you can customize all of this to meet your needs. And so this provides a really nice, clean experience. So you can keep the controls fitting in with the look and feel that you want of your application. We're really excited about this functionality, and we think you're going to love it. In the last 15, 20 minutes, we've been able to build an application that fully supports HLS and Dash streaming. We've got custom controls that we've tweaked to look great in our application, including custom buttons for functionality that's important to our application. And we've done it all with full support for user customizable closed captions. This is awesome. This is going to relieve a ton of pain points that we've heard from you guys and really make you happy. So I'll skip over these slides. I've got them for the people online if you want to go back and recap what I talked about. But the key message that we want you to be coming out of here with is you should move to the platform, but do so at your own pace. We know a lot of you out there have a lot of existing investments and using a lot of technologies to deliver Windows 8 and 8.1 applications, and all of those are still fully supported on Windows 10. We think that the platform provides a lot of really great value to you, and you're going to want to move to the platform and take advantage of it. So you want to plan that, but plan it within your existing business cycle and your development cycles. It's really easy to get to Windows 10, and there's no high cost. You don't have to go rewrite code. You don't have to move from smooth streaming to Dash. You can keep using the HLS SDK. All of this stuff just works, and you can move at the pace that makes sense for you. To that end, SDKs such as the Player Framework SDK, they're going to be updated in the coming months to take advantage of all these features, and so it'll turn to a thinner and thinner wrapper on top of the platform over time. So what did we talk about? First and foremost, we listen to your feedback, and we want more of it. It can be painful at times, but that feedback is critical to us. It's how we know what's the most important features for us to build to make you all successful. We're committed to making your lives easy and making it really easy for you to build awesome apps and make a lot of money on Windows. So give us this feedback. I've got an email address at the end of the resource section slide. I encourage you, reach out, tell us what you like, play with the APIs. If you like something, let us know. If you don't like something, we really want to know that you don't like it. If something new is hard, if there's a new challenge you want us to solve, that feedback is awesome. It's how we make sure that we build the features that you need. We've added support based on your feedback for gapless audio, HLS, Dash, custom controls, closed captions. They're all part of the platform now. This was hard in the past, and we've made it really easy for you, and you're going to love it. We think that with the changes that we've made, it's easy to build powerful media application on Windows. There's cutting-edge technology available for you to use to delight your users without having to take on a lot of pain and code on your side. So as you walk out of here today, remember, if you're building an audio app, to develop with background audio in mind. Think about that up front so that you can set yourself up for success. And focus your development on what makes your app great. Where you provide key value to the ecosystem, focus all your engineering efforts there. And for all that other stuff, that boilerplate, that cost of doing business, let Windows do that for you. And start using our features today. Everything that I talked about is in the bits that you've downloaded. You can start using the features today, and it's awesome. There is one small caveat I'll point out, which is our gapless support is coming in a future flight. The playlist APIs are available so that you're unblocked to start developing against all of this. And you'll get a few quick updates down the line to make this even better. So with references, mediafeedback@microsoft.com. Send us email. Let us know what you think. We've got a blog post that we sent out a few months ago. Talks about HLS and Dash in the browser. We've got API references. So check it out. Start using it. Tell us what you think. Thank you so much for your time. And if you send an evaluation, we'd really appreciate it.